start, we're going to do just a little get to know the audience a little bit. On a show of hands, how many of you guys are students? Yeah, that's a majority of you. How about mentors? Yeah. How many of you guys have used YASS before? This is YGSL, YAMS, y'all. Okay, we have a few in the crowd. So most of you guys are new faces to this, and in this workshop, we're going to be introducing all of that, which we're going to start in a couple minutes. More like 120 seconds. Oh, and if you're late to the party, we have ribbons and pins and stickers for you to grab before you start. We're going to begin our workshop now. How have y'all been doing today? Good? Yeah, that's good to hear. To start off with, I'm going to ask this one question. On a show of hands, how many of you want to make it back to Worlds again in the next season? That question is kind of obvious, right? That's why we're here. That's why you're here. Every team in this room wants to know how they can improve, design better and faster, and most importantly, win more. If that's you, then luckily, you're in the right place. In this workshop, we're going to be introducing tools and resources that can help you revolutionize your design process and help you level up your programming. Whether you're a first-year FRC student or a mentor who's done FRC for decades, I'm sure that Yet Another Software Suite has something in store for you. Before we begin, we're going to introduce our presenters up here today. I'm Isabella. I'm from 3481 Bronkbots, and I'm going to be your main presenter here.
And I'm Milan. I'm from Team 3481 Bronkbots.
I'm Sorish. I'm also from 3481 Bronkbots.
My name's Timothy. I'm from Team 2181 Gears.
There's an odd one in the crowd. Okay, now let's address the elephant in the room, and that is, what is YASS? YASS stands for Yet Another Software Suite, a collection of FRC tools and libraries designed to make programming easier. Designed to make programming easier and quicker. This allows you to spend more time or actually you're going to spend less time programming simple mechanisms and more time programming more fun and complicated projects. After all, everyone doesn't want to just program a turret for 10 hours just to have to tune it for 10 hours more. At YASS, we aim to spread our love for clean coding, abstraction, and streamlined simulation and advanced features for everyone worldwide. No matter what skill levels you have or what team you're from, you have something that you can learn from this presentation. Up here you can also see all of these logos. These represent our 3 libraries that are in YASS and our mechanism generator. Along with our little frog mascot, his name is Ribbit. I think he's adorable.
And here's some brief history about YASS. So several years ago, Swerve Drive started to take over Team Drive in the world of FRC drivetrains. They do allow robots to move in any direction instantly, but they are notoriously hard to program. Right? Saw this and decided to create some Swerve Drive library, which is now known as YGSL. YGSL is used by over 500 teams in 30 different countries in the official matches last season. YGSL then expanded into YASS, which now has more FRC tools that we'll introduce later in this presentation. YASS, YepGen, y'all, and more in the future.
Alright, first things first, let's talk about YAGSL, which stands for Yet Another Generic Swerve Library. You might have already heard of YGSL since it was the first publication by YASS, but if not, YGSL is a library that simplifies and quickens the process of programming swerve drives for your FRC robot. It was designed for the use of all sorts of teams. There are beginner rookie teams using YGSL to program their swerve drive, and there are world-class teams, maybe even some of you guys, using YGSL as well. When I first heard of the concept of swerve drive, I was kind of freaked out. Like, ooh, what is that? That sounds like intimidating, right? Because it has a lot of math to it and a lot of complex programming that requires to make a proper swerve drive. And I was intimidated, but I found out YGSL actually handles a lot of the complexity for you. So it gives you a base to to work off from. It's a plug-and-play library. Why should you use YAGSL? Well, there's two main reasons. First of all, it's very, very easy to use. I'm trying to emphasize this as much as I can. It's super simple to implement into your team. It's also very customizable.
Yeah, so YAGSL supports 3-wheel swerve drive, 4-wheel. It can be a square, a circle, a triangle, any shape you want, and also allows you to place your gyro anywhere on the robot, even vertical.
YGSL could also hypothetically work in 10-wheeled swerve drives, but that has not been tested yet.
In 2027, there are a couple cool little improvements that are going to happen. First of all, better, more accurate simulation, and also little optimizations filling in the gaps that haven't already been filled so that your swerve drive is as good as it can be without extra effort on your behalf, on your part. All right, YAMS, which stands for Yet Another Mechanism System. I personally really like the acronym YAMS, that's pretty cool. YAMS is a library that makes the process of programming your robot mechanisms, like your arms or your elevators, a lot simpler. Before I go into any details of what YAMS can help you do, I want to show you this quick little visual that I thought was to be pretty eye-opening. For some context, what you're looking at right now is two different elevator programs that were used to program the same exact elevator, same physical elevator that my team 3481 Broncos used in the reskate season. So I want you to take a look at the key as well. There's a clear difference between the original elevator and the YAMS elevator, and that would be that the length. The original elevator is so much longer than the YAMS elevator. If you check the key out, the original elevator has a lot of configuration and setup lines that the YAMS elevator reorganizes so that your code is cleaner and more organized. And as we programmers all know, cleaner, organized programs are better programs.
It's not only just cleaner, but you still retain the same level of control on all your robots. You're still able to import and configure your motor configurations. You add sim and have telemetry data, along with adding all your commands. But overall, it's just way simpler to use.
All right, so what can YAMS help you do in your robot? First of all, it's built for all skill levels. Like I said, for YAGSL, YAMS is used by beginners and advanced teams, and it scales with experience. So the longer you use YAMS and get to know its features, the better, the more advanced things you can do with YAMS. It simplifies programming, like I said in the visual. I think it speaks for itself. Did you see that length difference?
Yeah.
And customizable. You don't need to do anything extra if you're using a certain motor compared to another, motor A and motor B. You don't need to do any extra programming to use one motor over another. It just happens.
Mm-hmm. If you're just adding on to that, if you're using like a Rev motor and then compare that to a Talon, a Kraken, anything like that, programming-wise, very different. But YAMS makes it all the same. You can have the same program for both motors.
YAMS also has built-in live tuning capabilities. There's going to be a live tuning demo in a couple minutes, so I won't go into too much detail here, but it is a huge time saver when you're doing things like PID tuning. A lot of the best teams use it, but YAMS live tuning makes it very accessible for everybody. And finally, simulation, in my opinion, is the coolest feature. It has built-in simulation. There's also more slides on this later, but just to give you a two-sentencer, YAMS with simulation basically helps you check to visualize the behavior of your robot mechanisms completely virtually. So if your mechanical team is taking some time to put a arm mechanism onto your robot, instead of waiting around for them to finish what they're doing and then start coding, you can actually finish the bulk of the programming completely virtually before that happens.
This is just a little visual of what YAMS look like. Very clean. Everything you want to configure on your robot is right there. Your gearing or idle mode, everything is just there. You just do .with and you can see everything. Super easy to configure. Even your grandma can do it. If your grandma was a programmer.
So some of you might be wondering, why would advanced teams use this? Well, like I said earlier, YAMS is supported by YAMS supports all brushless motors and motor controllers, whether that be a Kraken, a Talon, a Rev Vortex, or Neo, or even 50 Novas. They're all compatible. And YAMS also makes exponential profiling and trapezoidal profiling available for all motor controllers, not just those made by CTRE, and also includes advanced sensor simulation. But by far, the biggest advantage is spending less time on your mechanisms and more on when maybe the build team needs slightly more time. You can spend less time working and tuning those.
Justice for programmers.
One new thing that was added to YAMS this year was easy CRT. So a problem with turrets is keeping track of the location, especially after you power cycle or re-push code to your robot. And one thought is maybe you could add an external absolute encoder, but you can't really do that because turrets' gears are big. So you need to actually use two, but when using two absolute encoders, there's a lot of complex math called Chinese remainder theorem, and YAMS does all that math for you. So all you have to do is feed it your two encoder values, and on startup, your turret will know its location, so you don't have to position it every time. Just looking at this, so on your left, you have just a regular PID, and on the right, we have an exponential profile using YAMS. The exponential profile is 100 times smoother and also a lot faster. And YAMS, this is normally only supported by CTRE motors, but YAMS makes this available for Rev and Thrifty motors as well.
Okay, so let's move over to the mechanism generator, YAMGen. So YAMGen is a web-based simulator and a code generator. Yeah, as you can see on the right side, YAMGen supports all motor vendors and all major mechanisms, such as arms, elevators, and pivots. To use it, users can put in information about motor configuration, such as motor type, gear ratio, and the mechanism parameters, such as arm length, center of mass, and then, as you can see on the right side, the generator will generate code that includes all basic configurations, methods, commands, and is ready to go.
Unlike ChatGPT, the code makes more sense.
Yes. YAMGen is highly recommended for the design team. Do you want to know whether a 5-to-1 gear ratio works for your elevator? Well, you can test it in YAMGen, and it'll tell you whether it works or not before letting your robot suffer in the real life. And for programmers, well, you want to get more tuning practices? YAMGen and the control configuration will be your best friend, and you can get more PID tuning and feed-forward practices with that.
Yeah, because you can actually put your PID and feed-forward values in here before anything was programmed. Let's talk about one of my favorite libraries, Y'all. I really like it because it's Y'all. Yet another Limelight library. A Limelight library basically just helps it integrate Limelights easier to your robot. Count how many times I say Limelight. On a show of hands, how many of you guys use a Limelight on your robot this year? Yeah, that's fair. Limelights are $400, but they are also not that very easy to program, which is why a lot of you guys use something called Limelight helpers. That's basically a class file that's over 2,000 lines long to make your Limelight configurations have more control over them. However, this class file is very complex. It's not very easy to look at, and also, learn, which is why we created Y'all, a vendor-based solution where you basically download the library and you have everything you need, and it is also be able to update mid-season, and you can use the same Limelight code for many seasons to come.
For example, the one I released last week with the 2026.1 update. I also added Java docs for every single parameter so that you can, instead of having to go through the Limelight documentation, figure out exactly what this NTK does, you just click dot, look at your IntelliSense and say, oh, that's what that is.
Basically, if you're illiterate, don't worry, Y'all is your best friend because we have improved API, super easy to use, super easy to understand, and basically has everything you need to configure your Limelights. Any questions before we go on? Yeah.
For the simulations, what library do you use and what level of precision are the simulations?
So for the simulations, we use the WILO physics physics process to handle everything, and everything is then passed down to the to the motor controller level. So everything. So if you are using vendor simulation, it will be entirely seamless because it does use vendor simulation under the hood. Go.
How does YAMG tell you if your gear ratio will work?
All right, so you know how WILO has the WILO dock simulation for the elevators, arms, and turrets. What we did is we took that and we made it generic and passed all those values through. So as long as it works in that simulation, it theoretically could work on the real robot, but that doesn't guarantee it actually will work in the real world.
Is this all open source?
Absolutely, everything we have made is currently open source.
What license?
Varying licenses. Actually, all does support object detection. it passes because of how Limelight does object detection in the first place. It will pass all the objects to the JSON file, which then you can fetch with y'all with the results object. I am planning on doing a little bit of changing on how you actually fetch the JSON file and versus the NT keys, and maybe adding a few more ways to communicate in the future. But yes, we do support everything that the Limelight helper supports, and a few more things that Limelight helper doesn't.
So I'm familiar with the helper library for Limelight, and I was curious what the difference is between the helper library and y'all's, aside from the documentation which I heard.
There is, y'all has more features than Limelight Helpers does, because it's based off of the API documentation that Limelight has published. But Limelight Helpers is basically one-to-one after.
Is there any plans to expand y'all to support Photon Vision or QuestNav?
Photon Vision and QuestNav both have their own libraries, so I do not plan on supporting them at this time. Maybe in the future, but there isn't enough parity to really warrant it yet.
Does it play nice with Advantage Kit?
YAMS does, y'all does. YGSL, it depends on where you want your boundary to be. Advantage Kit has commented on this before in their videos that they published. But with YAMS, as long as we even have examples for this too. So you have, as long as you process your inputs correctly and process your outputs correctly, you should be just fine.
Cool.
Just depends on where you want your boundary to be.
Do you guys have any opinion about the pronunciation YASS?
I pronounce it YGSL. I have given up on trying to.
Basically, how this segment works is that you guys are going to choose any mechanism, any motor to program, and we're going to program it right in front of you live. And this is going to be speedrun style, so it's a mildly simple mechanism. Any suggestion on what subsystem should we do? Turret. Hey. All right. Turret, and then do we want to include the flywheel with that? Sure. Okay, turret and flywheel, along with what type of motor are we using on our turret? What? What is? Kraken.
I'm not saying better.
We love Krakens, so that goes with talents. And then what else do we need? Next slide. Gear ratio for our turret. Any gear ratios? Name any gear ratio. 20, 21. And then, yeah, it's a turret. Does weight matter to it?
No, not at all.
Nope. Okay, we're gonna start now. All right. Let's pull up the speedrun timer and clear it. Clear it. Start. Go. All right. So we start off with a empty project. We built it already. Empty, including a basic template. And what we're first gonna do is download YAMS. Did you download YAMS already? Okay, YAMS was already downloaded. Can you quickly show that? Yeah, so it's just right there. It's a part of WPI-lib's libraries. And our goal, what?
It's part of the vendor dependency.
Yeah, it's part of WIP-lib's vendor dependency. You're gonna download that. And then while that's downloading, we're gonna start with programming our subsystem. Our goal time for this is going to be under 10 minutes, but of course this is going to be a little bit. So if you think it's going to be higher than 10 minutes, raise your hands. Wow, you guys really believe in us. All right, we're gonna start off with creating our smart motor controller config. And this configuration will allow you to configure your smart motor controller any way you want. Okay, so you're gonna start with creating a gear ratio. What is our gear ratio? Is 20:1. Okay, and then we're gonna do a smart motor controller loop. So something about YAMS is that it's very easy to include PID and feed forward into your mechanisms, as all it takes is 2 lines. One for your real life PID and one for your simulation. Because while it may work in simulation, it might not work in real life, because real life is different. Anyways, we're now also gonna add, what are you adding? Idle modes, which is right there. Going back onto the feed forward and PID thing, most PID programs do, if you're hard coding it yourself, you have to do the formula, and it's like a bunch of lines. It's all really simple in YAMS, 1 line. And we can create our idle mode, which is .break, and since it is a turret, it's very simple. Not that many configurations you have to do. You're going to create your smart motor controller, and you're going to pass through your configuration and also your motor, which we declared as it going to be a Talon or a Kraken using a Talon FX encoder along with the CANT91.
Kraken X60 or X44?
44.
X44.
44 first. All right. Now we create a smart motor controller. Let's see what he's gonna do next. Can you type faster? We have a timer going. Let's see. We're at 3 minutes. Wow. You still got to do the creating your mechanism, and then you also have to create all the commands and add sim and iterate. You know, chop chop. And a flywheel. Oh yeah, we're also programming a flywheel with this. This is 2 motors. Oh right, you already have the flywheel. Okay. You're creating a telemetry. Okay, so YAMS also provides all the telemetry data you would need. No extra code required. All you do is .with telemetry, add your mechanism name, and then add your verbosity. This should be kept usually lower during competition, as you don't want to overflow too much data. But once again, very easy to change. It's just 1 line of code. You're missing a semicolon.
I'm not even done yet.
Okay, now you're gonna start your starting position. So one thing about turrets is that you're gonna not, if you want to use an absolute encoder, you're gonna need to use the CTRT. Otherwise, you're gonna have to reset your turret to the same starting position on startup every single time in order to, for it to know where it is, its position accurately. And you can set your starting position, instead of being at 0 degrees, you'd be like 90 degrees with starting position. You're gonna also add your soft limits, as sometimes not everyone wants your turret to go 360 degrees and what's that word again? Decapitate itself. That's fun. And you can set your soft limits. Looks like it's at 0 to 67 degrees. We're gonna now create our pivot. So turrets are just pivots, and what a pivot is gonna be a motor that, or a mechanism that is not affected by gravity. The difference between a pivot and an arm or elevator is that arms are affected by gravity, right? Look, my arm affected by gravity, but my wrist is not when it's rotating. And now it looks like he's gonna create his commands. And in order to create your command, you might have to do some logic and stuff to get your motor in the right spot and making sure it ends at the correct position. Looks like it's just like 1 line. What is that parameter? The parameter he put was angle.wego here. We support clean coding, guys. Label your variables.
Why is it no camel case?
It's a speed run. We have no time. What's the timer say? We got 5 minutes.
That's an extra finger.
Run. Okay, so you got your command, set position, angle, and then it's going to return. You can just .run angle, and that just goes to the angle. Whoa! And that's because we already created our mechanism object, and so it has that all in the pivot class already. And in order to control it. We're gonna create our Xbox controller, and we're gonna create our triggers for that. And so it's gonna be the driver controller, port 0, and then put in our configure bindings. We are going to put it on the buttons. So if you don't know, in simulation, if you don't have a controller, you can just do .button, and that will work on one of your keyboard buttons. And then while true, it's gonna get a position. What is this? Degrees, dot of, units, and then you're gonna put how many degrees? 30 degrees. And then we're gonna copy and paste that. Our next one, it needs to be between 30 and 67 degrees. 10 degrees. That wasn't in my parameters. And then we're gonna have 0 to 10 degrees and 30 degrees, and that's gonna be our 3 buttons. And then is that done? Are you done? Oh, right, you need to set PID for it because PID 0 makes the motor object not move. And are you done?
0, 1, 0.
By the way, the button is wrong.
The button's wrong? Oh yeah, you have 2 0 buttons.
Oh, yeah.
You're wasting time! You're at 7 minutes.
So one of the nice things about YAMS is even if I didn't program everything correctly just now, in the stack trace it tells you what you did wrong and why. Unfortunately I can't do all this at compile time, so I have to do. Oh hey, did it right.
7 minutes.
Let's find out.
Alright, 8 minutes and 26
Nope,
seconds.
right there.
Oh,
All right, so.
confused.
All right, so what I was just talking about is that it will tell you what is wrong and why. So right over here, it's telling me that I'm using a FXS wrapper and unknown motor instantiating the FXS. So when you control Krakens, you have to use a FX. So, see, I can just read my stack trace and immediately know what went wrong instead of trying to figure out what. It will just stop. It will stop you from making those mistakes as you're going.
It'll stop you from punching your computer at 12 o'clock right before home.
Yeah.
To build the bills, time to pause. Let's see. Oh, it doesn't run.
Yeah.
What does it say this time?
Let's find out.
Let's see. It cannot create a simulation. Please set a angle.
So one of the things I forgot to do is because we do everything in simulation as well by default, it will tell you that I need certain parameters in the first place. One of the things that I need is the hard limit. So to add that, all we have to do is go back into the config.
Oh, awesome.
If your arm or turret is trying to go past its soft limit, YAMS will do its best job in stopping it from going past any soft limits you have. And you can also set your hard limits as well. And that, in real life, that'd be your physical hard stops. But in simulation, it just shows that it's going beyond its soft limits. And this is very useful when trying to debug, when you can be able to run in simulation and see if it works. Anyways, for whoever said that we're higher than 10 minutes, you have won the bet. You win all the prize pool money. Yay! To the one person that said that. Let's see what it's reading out this time. Oh, what does it say? Oh, you forgot your mass. I told you we needed the mass. How heavy is our turret, guys? 10 pounds. 10 pounds. And then let's see if it runs. It stays. And with that, that's the end of our speed run. 11 minutes and 50 seconds. Can you program an arm in a turret in 11 seconds? Because I can't. 11 seconds, 11 minutes, my bad. And this is what the simulation view looks like. It's very beautiful, very majestic. You got 3 very beautiful lines. There's actually more lines than this. And they represent your hard limits and soft limits. And if you see that white line here, that's gonna represent your set point, and then the orange line is gonna represent where your turret location actually is. And you notice when we go to our buttons, it's very much wobbling around its set point. Do you guys know what this means? PID tuning! And also some something severely broken of our turret, as it's going beyond its hard limits and soft limits. Did you set hard limits? Cool.
Now you can demonstrate pit tuning.
Yeah, live tuning. All right. In order to pull up live tuning, it's gonna be built into Advantage Scope, and you're gonna run a command in order to activate live tuning. So you have our our elastic here, and you see our flywheel subsystem, and then we're gonna pull out our turret subsystem, and then we're going to run it. And so we technically did not start on a clean file. Maybe it was bad karma. But yeah, we have our flywheel, the arm, and all you have to do is press this live tuning button, and it runs a command on the command scheduler. If you press a button or V-stop or anything like that, it'll stop your live tuning command. So don't worry, it cannot make your robot go haywire. And now, okay, you're gonna need to scroll up. You need to do the little line things. So in order to activate live tuning and be able to set the things, you're gonna have those 3 lines on the top right next to the search bar. Click on that, and you're able to edit. It's gonna turn Advantage Scope into edit mode, and you're able to edit like the PIDs and whatnot. But first, we're gonna add our stuff into our graph. So our set point position, our current turret location, and then we're gonna be tuning it live in front of you all. All right, let's get this on, or turret. Keep calling it arm. All right. So let's start by setting the position to some random position that is not 0. Oh, Brashy, let's do our PID tuning steps. Start with feed forward until your turret moves, but our turret already moves because it weighs like 10 pounds. And so, okay, you wanna commentate? Okay, been denied. Let's see. We're creating our, our simulation's broken. So that is a clear indicator that there's something logically going wrong in your mechanisms. Whereas before, if you were to run this on a real robot, what do you think would happen? Rip a couple $1,000s and maybe, a lot of time. And I think that's the beauty of simulation, is that you're able to test and tune in a safe environment without causing more trouble, and you're able to do all of this well before the robot is built, well before mech team is done, Instead of programming the day before competition, you can be doing it the whole season. Have a whole fully simulated robot thanks to YAMS. And then in the future, we're also planning on supporting simulation for limelights as well, as long with having a more accurate simulation for our swerve drive library, YHSL, or also known as YAXL. And then can you demonstrate the position moving when you change it? All right. So if we move the position to 25 degrees, you did not have to push code, you did not have to redeploy, and it just moves. And then you can set your PID a little bit higher, and then can you move it to like 0 degrees, just to showcase? 0, yeah. And it goes, and you can tell that, hey, it's not reaching its set point, or it's hitting its soft limit, and it's live tuning, right? No need to deploy, save use time. Instead of tuning for hours and days, you can tune it in minutes. And with that, we're gonna end our live demonstration segment, as we're gonna be running out of time. Where's your campus slide? Simulation, very powerful. We talked about it earlier, but you can simulate from everything from your swerve drive to your mechanisms, all the way to your pivots and elevators. And it's a great way to safely learn and experiment on new things. Test code without a physical robot, and it's very accurate, and it's as accurate as you want it to be, as you're able to customize how much weight and everything it's in YAMS. We also have documentation for both the literate and illiterate. We have our awesome example page on GitHub, where you can just copy and paste for all of your likings, as we have examples of all types of mechanisms and customization options. We also have YouTube tutorials, because for me, I really hate reading. So these tutorials walk you step by step, being able to create every single mechanism, whether you use YAMS or not. And then we also have our awesome documentation. As we're in fact well documented, we have a very clear API and also website links for all of our libraries and mechanisms generators. Now, do you want to get involved? Being a partner team will get you access to beta testing and all the cool, awesome stuff. But in order to become a partner team, you're going to need to do a couple requirements first. One, be active in our YASS community. You can do this by beta testing or being in our YASS Discord server, and overall help promote YASS to everyone in your local community. You can do this by creating documentation or just help promote it in social media. Partner team. Being a partner team gets you lots of benefits. You get to represent your team in Partner Team Pink. It's basically like our ambassador program. We help also drive development for more features, and you get the latest news on all these new features before they all come out, such as beta testing. And then you also get priority support, and then exclusive merch and Discord channel. But YASS isn't just about code. It includes open source examples, weekly workshops, YouTube tutorials, and a 24/7 help desk, all of which you can find on our links up here. You can join our Discord server, discord.gg/YASS. We're the largest programming server related to FRC. And then the YouTube and Instagram page is at yassrobotics.com. Get up to date on the latest features. And if you're interested in anything that we talked about here today, you can check it all out on yassrobotics.com. And with that, we're going to conclude today's workshop. I hope you learned something new today, and through the power of abstraction, optimization, simulation, and more, I hope you find that yet another software suite has yet another solution for you. We will now be taking questions.
Is there some sort of tutorial that you guys have, or some other team for guide to it?
Yes, so our tutorial page, everything is on our yet another software suite, but we have tutorial pages for everything from programming to live tuning. We have a document page for everything, and then also, of course, our YouTube channel that will walk you step by step through all of this.
Does YAML support hardware abstraction?
Does YAML support hardware abstraction?
Depends on your hardware abstraction. It depends on your hardware abstraction. If you are referring to the HAL layer that's normally exposed in WLib simulation, yes, it does do that. It does do that for everything applicable. However, it doesn't do that for solutions such as Candy, because
One last question before they kick us out.
Maybe more of a request. I was looking for documentation on how vision telemetry can be added into the Swerve drive, ongoing telemetry. I found documentation to be somewhat sparse.
yes, that is not something specific to YAMS, YGSL, or DAL, unfortunately, because that is it is added to localization via the Swerve drive pose estimator, which is a WGADLib class, so we would expect WGADLib to have documentation on that, or anyone else. But if you find any documentation for the Swerve drive pose estimator.add vision measurement, it is relevant to YGSL and anyone else who uses WGADLib classes.
We also have an example of YAL, a Swerve drive using YAL on our GitHub page, if you want to reference that, as that has worked for multiple seasons now. Awesome, if you want free swag, we got pins, game pins of all different pride flags. I think they're really cute. We got stickers, banners, we got everything up here. Take them all. We also got candy. I want all this stuff gone. And thank you everyone for being here today.